Okay. Shall we start? Anybody who has done it? You want to do it? You have a question? Okay, go ahead. Ah. Hmm. 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 0.13. There's something wrong there. Yeah, something wrong. Cannot be that much. Just take a look at the code. And if nothing helps, then just go step by step to see what is different there. It should be higher or it could be even lower also, but cannot drop that much. Just try to rerun that, some of the algorithm. Any other questions? Randomized search? Test accuracy is 0.82. Okay. Okay. Anybody else has got any output? You're done as well, Arpan, right? So yeah.
Overall precision 0.76, overall recall 61.
Okay. How many of you are still working on it? Few of you already working. I mean, still working. Shall we do the name picker then? Let's see who's the lucky one. Poonam, you have picked, but you have some problem with this. You want to rerun that and then confirm, right? Abu Bakar. Doing? Santosh. Still getting some error. Rahul. Mohammed Idris is not here. Tarun. Online. Anupam. You've done it?
Yes.
You can share your screen. I'll stop sharing so you can begin sharing. Yep, it's visible, Anupam. You can go ahead. He's audible on the Teams? Okay. Yeah, go ahead, please. Today the lunch break will be at 1:30, so we have more time. So Abhi just informed that we are gonna go slightly later today. We'll plan accordingly.
So, can you hear me?
Yes.
Yeah, somebody's confirming online. Yeah, you're audible.
Distribution. be on a survival 6 in weeks. I noticed that in terms of vacuum, how many males and females. So further did the passenger classification by survival. After that, what is the age distribution within that? So that's what I was able to find out that parent was still, I think I was able to got a huge match. So which really the information about the survive, not survive, and the all of the parameters which were there in the file. I think the data being dropped certain features like class two, adult male, like always, and then missing values which I had to remove. Created the family size, then went into categorical variables whichever were there. Then defined that in survive, put it as that across. Train the data with a random state of 48. Again, first model which we created, it gave me a data of estimators, different criteria which we use G. Bootstrap true, then random state was 42, which we got. In terms of prediction accuracy was 0.81%, which I got in the accuracy using RF predict.
Where are the parameters, Anupam? What parameters have you tried?
So I'm coming to that.
Okay, you're coming to it. Okay, got it. Yeah, carry on. So you just tried one without the parameters and then you're coming.
Yes.
Okay.
The feature which the parameter which I will actually look then the most important feature in purpose was face, which gave me that confirmation to the top feature. And the tree then formed the tree in terms of the six. So what is the tree which we were able to get? So yeah, that's how I did it.
Okay. And then parameters, number of parameters, where did you optimize? So you've done with one setting, I believe. You need to try with other parameters as well, like the number of trees, the max depth and stuff like that. That's what you would try, yeah. But good, thank you for sharing that. We'll do one more. If you have done the parameter optimization, that is. Karthik. Karthik is here. Yeah, Karthik, go ahead. Have you done it? Still working on it. Okay. You can finish, Karthik. Santosh. There are two Santosh, Varanasi and then normal Santosh. Who's Varanasi? Varanasi is online. Okay, so this time you have been picked, Santosh. No, that was Varanasi. You have done it or it's still working on it? Okay. What error you are getting? Okay, we'll see. Sachin, good to go? Thoya, picked up the phone at the right time. Ajit. Deepika. Done or not done? You need more time. More time. Are you done? Then present. Abhi, you can give her the access and everything. Don't be shy. You can present whatever you've done.
The other one, such we have the scoring, so we can give it as string in the way we call it. So then you need to refit it to a parameter which you want to optimize, which it is to be optimized.
Okay.
Okay, finite and it is saying refit and accuracy. This is then based on your requirement, you will have to get this parameter and the
That's right. That's right. Yeah, that's right. So there are cases where you will say, I am really more inclined for having a high precision, right? Versus high recall or F score or accuracy or AUC. So The main idea is that you can define that and you can use it to optimize that parameter. So it will look into those settings which give you the highest recall, settings which give you the highest precision, right? And that's how basically we look at it. Yeah. Yeah. Go ahead, Deepika. Some challenge? I'll give you a walkthrough of this as well. I mean, like what I've done, which is slightly different from my blog, but as long as you're following the blog, you'll be doing the same thing. But I'll just, for the benefit of the rest of the folks who are not able to run the output till now, you can look into this. Sure. Okay. We'll do that. Yeah. But those steps have you covered or you're adding from your side? What are the steps? What is the? Hmm.
Optimization.
That will be covering, then we'll do that. I have to cover that. So we'll come back to it later on. Hmm? Okay. Yeah, we haven't covered that. So I'll talk about more like, the trial and error, and then we can come back to it later on. Yeah. Nope. Not able to do? Okay. I'll share this code with you. So people who are struggling, you can match where exactly things are not working for you. Again, by email, and then Abhi will share in the WhatsApp group, but I just wanted to give you a walkthrough as well. But we'll wait for Deepika to come online. Yeah, go ahead. Mm-hmm. Yes.
Yeah. So title is .info. Hello.
Carry on.
Yes. So here I can see age, which has like null values, and deck. So embarked. So I'm dropping the unwanted features, redundant features, and again taking the info, and now I can see age. I have to fix the age and embarked.
Mhm.
So removing the duplicate, calculating the duplicate sum, and if it is greater than that, removing it, and fill null value. So age, I use median, and then embarked, since it is categorical, so I use mode to fix it. So now it is 891. Data is ready. The sample 10, and here embarked value count is displayed. So here and all, just so I'm just taking the object and encoding it to values, the category into values. So now all are integer and float and quantile. So this and all, I'll jump directly into yes, yeah, model fitting. Yeah, so here train test split, 30% test and rest or train. So used random forest classifier, and here n estimation is given. So n estimation is number of decision tree in the forest, and maximum depth is like 5, 10, and none. It can be picked by the system, and minimum sample split is 248. And minimum sample leaf is 1, 2, 3, and maximum feature you have given square root or log 2. So here is the explanation on each. And random search CV is a randomly selected parameter combined train model using cross validation much faster than grid search. But I've used a random search CV with this parameter in iteration with 15, and CV is 3. So total models will get 15 into 3, that is 45. And RF best prediction and the accuracy scored by passing test and Y prediction. So total accuracy which I got is 79%, and precision non-survival 81 and 78. Recall is 88 and 66. So RF rest feature is explained and then plotted here.
Key features which came out.
Yes.
Anything else we don't highlight?
That's it.
And then you're utilizing all of these.
Yeah.
Very close to being tracked. Okay, sounds good. Any questions for Deepika? Thank you. So if not, then I'll just share my screen and address any questions you may. Now? All good?
Yeah.
Hmm.
In the grid search,
Hmm.
you have linear entropy,
Hmm.
but in the grid search, you don't have this.
You can add them. You can add them. It's basically the list of the dictionary that you, so any parameter. So remember, I mean, like we had one more parameter that I'm not using over here, which was the like, you know, square root or the log 2. So that I don't have. So this one, Gini and entropy. That's okay. You can add. So like anything which is there in the tree can be used in the random forest. Anything that you're optimizing in a tree can be used for the random forest optimization. But the random forest will have, like, you know, this special criteria, which is not applicable for a decision tree because you're only fitting one tree. So that's the main difference, right? Class weight balance, that means learn from both classes, random state just for the replicability, what we're looking at. And then from over here, I'm importing the grid search CV. So in your case, you are looking at the random right? Just to really make sure that you don't spend too much time because I've run it already. I mean, that's fine. So just a quick explanation. Grid search CV estimator is the forest, the instance that we have created. Cross validation is fourfold. Scoring can be your precision, can be your recall, can be your accuracy, can be your F1 score. It can be anything that you want to have, right? So depending on what your business use case is, you can choose any one of them. So in this case, I'm choosing recall as the scoring criteria. So that means please give me those settings which help me maximize the recall value for my tree, right? Or for my random forest. And then I'm passing on my dictionary as you've done earlier on. The syntax may be slightly different from what you're looking at, but it's nothing but passing on the dictionary. This is where your fitting is happening. I think Poonam, you had a question where we are doing the fitting and transformation. We will only be doing the fitting over here, right? No transformation required. Fit meaning that it's learning the behavior between the X and Y. Once it has done that, it has fitted the instance. And then, yeah. And then we come back. And so remember, this object is called grid RF. Grid underscore RF is the object that we have fitted, right? Using that, we are doing the fitting and everything. And then grid underscore RF dot best parameter methods will give you what settings are the best performing settings for you. When we say the best, that means what maximizing the recall. So what gives you the highest recall? Which settings give you the highest recall? Now the settings which give you the highest recall can be different compared to the settings which give you the highest accuracy. Right. So in this case, we said, okay, please give me the settings which are giving me the highest recall. So those are your Gini, max def 10, minimum sample split 10, and so on and so forth, right? And number of estimators is 10. So this is not really a very dense tree. Yeah, forest, sorry. So in this forest, we only have 10 trees, right? So in fact, we said, okay, you can have up to 100 trees and up to 1,000 trees. So it says, no, you don't really need to overcomplicate. Your forest with 10 tree is good enough for you to get the best recall value, right? So again, something that is simple is always preferred, provided that we have the best value coming out in terms of the metrics and everything. So simple and yet highest recall is what we're gonna prefer. So that's what we are having. So the best score, that's you can add other parameters also, right? So there are many settings that we haven't spoken about in the random forest. You can see, how it is going to do the sampling and other things which are part of that. So you can definitely try. Huh. You can try that. So, and then the best score is nothing but your highest recall value. And then feature importance is, which features are coming out as the most important that you've done something earlier on. Now, I got the recall of 0.72 and 0.93, right? Because I have tried some other parameters as well, which is, over here, when we initialize that object, I also had the class weight balanced. So I don't know how many of you tried that or not, but that also plays a role in getting a higher recall value. So because of that, I got a recall of 0.93 and 0.72. And if I compare this to the same sort of tree that we fitted earlier on, somewhere over here, the recall was 0.88 and 0.61. So random forest did in this case give me a slightly better recall value compared to the decision tree, right? And then what we can do going forward in this is then you can do the prediction as we have done earlier on and all of those things. It will also give you the parameter grid. So for example, you can say, tell me please what parameters we have tried. So it says, all these parameters are something that you have tried. And then these are the best parameters that gives you the best performing tree or the random forest. Is that clear, folks? I'll share this notebook with you so you can fix any errors that you're getting. Anything that is not clear to you, you can make a attempt. You can take an attempt later on to fix those things. Shall I move on then? So the part that I'm going to now talk about is the threshold optimization. And remember, any model, when you're doing the classification, and this is, like, giving you the intuitive sense of, how the threshold optimization really works out, and not necessarily the only way of doing that. There are many, many other techniques that you can use for doing that, right? But I'm going to talk more in terms of the intuition like we've been doing so far. So let's go back to our decision tree. And I think you guys would have already gotten the output last time around this. So, okay, in this case, I think I'm using my random forest, or did I use the decision tree? So let me just check very quickly. I think I'm using my random forest. No problem at all. So, but same thing you can do in your system as well once you have the output working for you. So let's say, or this is actually the, yeah, this is on the decision tree. But this is from the previous class where I fitted a grid. And then in the grid, we got the best setting for the decision tree. I'm using the same object. You can do it on the random forest also. Nothing stops you, right? So when I say grid.predict proba, and then I pass on my X test, right? If I just do predict X test, what it will be giving you? Zeros and ones. If I just do the X test, grid.predict on X test, it will be giving you the classes. But I'm not looking at that. I'm saying predict proba. That means predict the probability, right? So you get the probabilities of what those classes are, right? Like probability belonging to the class 0 and probability belonging to the class 1 for the respective rows that we're looking at. Is that clear? And then we are doing, some fancy stuff. Again, you don't have to worry copy pasting this. You can do it later on. So then we did some fancy stuff, and then we basically got all of them to be tied together. So probability for the class 0, for the class 1, and predicted class and actual class, right? In this case, the probability of the class 0 is 0.71, which is higher than the default probability of 0.5. For a binary class, the default probability for the classification, this is for the binary classification, the default probability is 50%, right? Or 0.5. So in this case, the probability for the class 0 came out to be 0.71. Hence, the class has been assigned as 0. And the actual class is 0. So it's a good classification, right? Let's pick one more example. Something which is slightly more borderline. Or maybe not in this example. Yeah, that's okay. We can say, okay, anyway, so I think it's coming in very, very close, either side. Yeah, let's see this one. So this one, it says 95% probability of survival, and then almost 5% probability of non-survival, and hence the class has been defined as a survival, right? So this is the predicted class, and this is the actual class. Again, a good classification. So far, so good. Now, let's say I'm not happy with this. So what I can do is I want to change my threshold. So instead of looking at my default as the 50% for the survival, I can change that, right? So how can we do that? And before I go there, I'm just showing you something. So in this case, for example, we say np.round predicted probability of 0. Predicted probability is nothing but the object that we had created earlier on over here, which is the predicted probability. From this, we are doing the prediction for the entire X test array. And then from there, we're only showing the 0th member, right? So remember, it's going to be predicted probability is going to be a binary 2x2 array. 2x2 array when it's spitting out the thing. So it's not completely printing over here, but it's a 2x2 array. You can tell, again, going back to the Python days, because it has double square brackets. So it's a 2x2 array, right? So rows and columns, right? So when I say predicted probability 0, that means basically it's giving the entire row and column, which is sitting at the 0th location. So it basically comes in and says the probability of the 0 is this, and the probability of 1 is this, right? If I did not do any threshold optimization, what do you think will be the class for this, the predicted class? Survival or non-survival? non-survival, right? Because the predicted probability for the non-survival is 74%, for the survival is 25%. So this person will be classified as a non-survival, right? Or zero ultimately in the prediction. Now, what are we doing over here? You can say I am artificially changing that threshold. So test case. So instead of saying, that one, so I'm saying if the test case, now test case is nothing but this unidimensional array, right? So the test case is nothing. Let me just erase this portion so that you can see. So test case is nothing but this object right over here, right? It is one dimensional array with two members, 0 and 1. So I said, tell me, is the number in the test case 1, which is 0 and 1, more than 25 or not? So what do you think will be the answer? It will be yes or true in the binary format. It will be coming back and say true. So for the test case, which is nothing but the very first member that we did the prediction on, we are saying, can you tell me, is this probability higher than 25% or not? It says yes, that probability is higher than 25%. Are you guys with me so far in this? Now just extending that. So now we are saying, okay, I don't want to just do the test prediction for one row. I'm saying for all rows. And if the predicted probability for the class 1 is more than or equal to 25%, you give me trues, right? So now you can see the very first observation becomes true. So it says, yes, the predicted probability for that in the very first row is more than 25%. So this class is now defined as a survival. So what I have done is I have artificially dropped the threshold from 0.5 to 0.25. So this was, what my earlier survival probability threshold was. Now it has become 0.25. So I'm saying that as long as you think there is a 25% probability that this person is going to survive, classify them as a survival. It's as simple as that, right? So now, yeah, go ahead. Exactly. So that's what we're trying to do. That's what we're trying to do. So we're trying to modify, get the higher recall. So we're saying, I don't want to be living with the 25%, 50% threshold as a default. I want to maximize my recall. So in order to do that, I'm going to drop my threshold and see whether I can get a higher recall coming out from there, right? So that's what the experimenting, right? So there are techniques, that you'll be doing, but I'm just giving you the intuitive sense, and you can, of course, get a better code written on your own. So now you can see this person who was earlier classified, if you remember, over here. The same person, I think. No, it's not the same class, but over here, I think we are looking at. Yeah. So in this one, the same person was classified as a non-survival in my 50% threshold. This was classified as a non-survival. Now, what I've done is I've changed the threshold down to 25%, and this person is now classified as a survival, right? So you can see now all the trues, false, and everything coming in. Now, using this grid, new grid, we can go and recompute our. I think, I've not run this one, but you can see using the new grid. This is the new grid survival rate, and then this is the actual values. I can get my recall to be changed and the threshold to be changed, and then precision recall can be optimized as well, right? So I haven't run that, but let me just go and run this on the other side so that you can see what will be coming out. But that's the main idea behind that. So let's say I define this as my new test, which is following a threshold of 50, not 50%, but 25%, right? So I get the true false. Now I will go and I will run it. So this is my actual one. And then using the new test now, you can see it has suddenly made this recall value 80%. So you guys can see the difference coming in. I don't have the pen over here, but this is what my recall was with the 50% default threshold. And this is what my recall has become with 25% threshold. So if your objective was that you have to maximize your recall, you could have done many, many different things. Like, so you could have done like going with the scoring criteria, right? Scoring criteria, you could have made as a recall to really maximize that, right? The other thing you could have done was go from a decision tree to random forest, right? Or from random forest to some boosting technique or some boosting technique to the stacking and all of those things. And the third thing that we are talking about is you can do a threshold optimization on top of that. So if somebody said, you know, your job is to really come out with the best possible recall, you should try all of them. So instead of scoring on precision and accuracy, I'm going to score on the recall. Instead of fitting a simpler model, I'm going to fit an ensemble model. And after I have fitted the ensemble model, I can still go ahead and do the threshold optimization to get the maximum possible recall value. Is this clear? Right. So these are all the things where you can do, and this will be definitely something which will be there in your exam. Now, everybody suddenly is going to pay more attention, where you have to apply all the optimization techniques to get the best possible value of your recall or precision or anything else, right? So you can try multiple versions of the model. So model A, model B, model C, and see what gives you the higher recall. You can try the balancing of the classes. You can try the, scoring criteria. You can try the different threshold optimization, right? But threshold optimization will definitely be there with you. So having said all of this, so you can see this is how we can control the behavior and we can get a better output. I think this was in my actual code. So you can see if I did not do anything else, the only thing that I did was just threshold optimization, I would still get a very good boost, right? So almost like a 10% improvement in the recall from 0.72 to 0.80. Now, what took a hit because of that? If you compare these two grids, what went down? Right. So you can see the numbers for recall, recall for 0 also went down, right? So because I wanted to get a higher recall for 1. And then I also had impact coming in the precision. So there's a trade-off happening between a precision and a recall. So if I want a higher recall, precision takes a hit, right? If I want a higher precision, recall takes a hit. And that's where you have to prioritize things depending on what you're looking at. Is this clear? Any questions on this? Yes. Yeah. Yes. You can show that, but I just want to, show them the intuitive way first, because there are algorithms which will try different thresholds, and then they will do the the curve and everything, and it will tell you this is the right threshold for you. But at least you should understand when I change the threshold, what really happens underlying, right? So it basically changes the classes itself, right? So now instead of looking at those original classes, it says, now your new classes are this. And because your new classes are this, your confusion matrix looks different. Because your confusion matrix looks different, you have a different precision and recall coming in, right? So you can optimize different ways. So just one more thing I wanted to quickly talk about. Yeah, and you can change this. So for example, now instead of doing this, I'm changing this to like only when you have the, let's see who can interpret what this really means. So we're saying only if you have the probability of surviving as 90% or higher, I'm going to mark you as a survivor, right? So what do you think will happen now in your confusion matrix? Right. So you will have more non-survivors, right? And your recall will get a hit. So let's see what this really looks like. So I'm going to run this one. So now you can see all of them are false, 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 right? So very few have the probability, which is more than 90% survival. So most of them are classified as a non-survival. So the recall for non-survival is going to get a boost now. And some of the precision number for the non-survivals also will be looking better, right? So let's just see how it looks like. So remember, this is when I said 0.25 threshold, this matrix right now, I'm going to now say 0.9 threshold. And you can see what really happened. Recall for 0, 100%. All the non-survivals are detected. What happened to the recall for 1? it took a really very big hit, right? So 0.38. So you're only able to detect 38% of the survival. Precision for the 1 is fantastic, 1. So you can see how with the same prediction, you can make the confusion metric looks very different compared to what you're looking at, right? So this covers a high level walkthrough. Any questions, comments? We should use it depending on what you're trying to optimize for. So remember over here, when I was drawing this, you should use all 3 levers. What are the 3 levers? Your scoring criteria, right? Whether you want to maximize your recall or precision, your different models. So whether you want to go with a model A or model B or model C, and then your threshold optimization to maximize that. No, I'm saying if your job was to maximize the precision, for example, yeah, or if your job was to maximize the recall for 0. So remember in this one, recall is still really good, but only for 0, right? So if your business objective was that I want to maximize the recall for zeros, then you can use this threshold, no problem at all, right? So like, let's say if I built a fraud detection model, right? If I use the default probability of 0.5, a lot of fraud cases will skip, right? A lot of fraud cases will skip because I mean, only when I'm having 50% probability that this person is going to be fraudulent, I'm doing that detection. So instead, I can say, you know what? Even if you have 10% chances or 10% probability that this person is a fraudulent, flag them as a fraud, right? So that way I'm going to maximize my recall for the fraud detection. So I hope this makes sense to you today. So this is actually used. So I'm dropping that threshold instead of 50%. I'm saying even if you find that there's a 10% likelihood, like in, let's say you are, since nowadays, I mean, you have a lot of these spy thrillers, right? So, and you have built a model to detect some sort of conversation where something is being planned against the country, right? You don't want to wait for 50% probability to be certain, right? Even when you have 5% probability that, yeah, this looks like a suspicious transaction we should be looking at, drop that threshold to 5%, right? So, and then flag it. That's something that the intelligence agent should be looking into. So that's the whole idea behind that. So it all depends on your business use case. Other questions, thoughts from anyone? Hmm? Sorry, say it again. No, feature importance will remain the same. So remember, the model that you're building doesn't predict the classes directly. It predicts the probabilities. And underlying probabilities are not changing at all. You're not messing up the probabilities. Using that probabilities, whether you define that as a 0 or 1, is all you're doing in the threshold optimization. So feature importance doesn't change in this one. Yeah. Any other questions, thoughts? So I'll share this notebook with you. So people who are not able to do along with me, you can definitely do it later on. Yeah, you can share now. Arpan, what do you have? Yeah, you can share. In the meantime, I'll share this notebook with everybody else. Yeah. Huh. Yes. Keep on adding those layers. So that's why I'm actually sharing this so you can do it later on as well. Yeah.
Yes, here,
Yeah. Good.
index or statistic.
Hmm.
So here,
Mhm.
so and this one is 2.5 minus one positive rate. So each threshold, it will calculate Newton index. And if Newton index we define as a J, if J is near to 1 means it is very good. If it is 0 means it is very bad. Now, using that I am calculating base threshold, and for that particular threshold, whatever Newton index says this is the base, which is the true positive rate, which is the false positive rate, and what is the J value here.
Yeah.
So Newton index or Newton statistic is 0.594. This is the base threshold as per the formula what it is having. And for this threshold, true positive rate is 0.70. This is true positive rate.
Mm-hmm.
And false positive rate is 0.10.
Yep.
This is also good. And Newton index is 0.61. It is near to 1, means it is we can check. This is we can say this is good threshold. And now after that with that threshold, I have compared these two. So this is with by default is 0.5 threshold and optimal threshold what to get
0.59. Yeah.
Give it. So
That's right.
you are were giving, so for example, precision of survival, it is given 0.78, 0.6,
Yes.
0.78.
Yes.
And recall is also for non-survival, it is increased, but this is also decreased, the recall of survival. And F1 score of non-survival, it is also increased here. So I have compared this.
Yeah. Okay, good. Yeah. So there are many different techniques for doing this threshold optimization, more automated fashion, but you get the intuition of what exactly it does, right? And how do we optimize for the threshold that we should be looking at? Any question, folks, from anyone? Are we good on this topic? Shall we move on then? So then, in interest of time, what we're gonna do is have you guys read through the article number. Where is it gone? 34 right here. K means clustering. So take a look at this for some time and then we're gonna kick off the conversation. So we'll do a time check on maybe 12:45 after you've done the reading, and then we'll be building this. Thirty-four article number. 34. Shall we start, people? Anyone who would like to talk about what did you understand? What is clustering and how is it different from anything we have done so far? Yeah, you'll try. Okay, go ahead.
Where we don't. We're trying to just really classify.
Mm-hmm.
Hopefully,
Okay, what else? Hmm.
we're trying to central point of the cluster and then trying to look at cluster.
Yeah.
That's what I understood so far.
Okay, great. Any other people? We'll come to you. Yeah. Yeah, go ahead.
Basically, we're using this because we need to put down the set points where they exactly point. So we are using it for analysis. That's why we are using the unsupervised learning. So that at least we can do the analysis. Second part which means is that this data set into cluster. So we know that data is divided into clusters. It looks at the mean, which is the square root of the point and the centroid minus some of that, find the actual centroid. And then tries to find the mean of that particular cluster over here. So this is important because then you come to know that how much is it your data, where exactly is it comes to. So you can further go ahead and do analysis.
Anybody else? I'll come to you in a minute. Anybody else? Any point of view?
This algorithm, what it does, it groups different data points with a similar cluster. Based on the distance, it will learn the pattern, and it is especially useful in image compression, distance calculation. The mean calculation will be equivalent.
Okay. Any other volunteers? Arpan?
So this is unsupervised learning where we don't have any levels. So for example, in Titanic data set, that's an example. We want to divide the passengers between who are from class 1, class 2, class 3 based on the fare. So it will check who are in class 1 means all the high fare who has paid more, they will be from class 1 or little bit lesser than in class 2 and low fare in class 3 kind of things. Now, when in this case, we don't have any Y in data set, therefore we don't have any level. So whenever we don't have any level, we can use k-means clustering to check which category that new data comes. Now, to work on class
Somebody is unmuted. Okay, yeah.
K means number of cluster. So how this works is if I am having some data and at first it is iterative process. So at first it will if for example I have given k equal to 2, so 2 cluster. So at first it will randomly pick 2 centroid means 2 center point. Then from all the data points, it will calculate Euclidean distance from this particular 2 center points. And based on these 2 center points, it will decide, it will come from first, it will near to first cluster of first centroid or second centroid. So like that, it will be classified in 2 clusters. Now this iterative process, when you get the 2 different clusters, now for 1 and 2 clusters, again it will calculate the centroid. And for new centroid, again it will calculate the distance between 2 clusters. So when it will stop is when it did not find any new changes or new clusters. That time it will stop the iteration. And when new data will come from that particular data point, it will calculate the calculated centroid, which final centroid. And when whichever distance is lesser, it will assign that particular new data point to that particular cluster. It will work like that.
Okay, great. Yeah, so thanks for all of your inputs. That's all good. So I think, as most of you have pinpointed that this is an unsupervised learning algorithm, right? Unsupervised algorithm. So what does the unsupervised really mean? Yeah, so that means that there is no label. Huh? I'm not sharing. I'm not there on the Teams itself, actually.
Yes.
I'm there? Where?
Just maybe this is
To unmute. Now? Okay, I can hear myself, so I'm good. Yeah, so this is unsupervised learning algorithm. That means there's no label, right? You can also say that one way of saying that, and then you can also say that there is no ground truth. Right? So what do you mean by ground truth? That in the case of Titanic, we knew who survived, who did not survive, right? In the case of the housing price prediction, we knew what was the actual house price, right? So clustering doesn't have that, right? So, or this not just clustering, but unsupervised learning algorithms do not have that luxury that you know what really it is, right? So, and clustering is the very first algorithm for unsupervised that we're trying. And clustering is the statistical name for nothing that but we call as a groups in plain English. It helps you form the groups. So if you were to form the groups in this class, how would you form the groups? Like, what can be the groups over here?
Age.
Age, yeah, okay. What else? Age can be used for forming the group, yeah. What else? Huh? Gender can be used for forming the group. Okay, what else? Number of years of experience, yeah, okay. Height, somebody mentioned, right? So tall people, short people, medium people, right? Three groups: short, medium, tall, right? Or gender, females and males, right? Or what was the other criteria? Age, right? So less than 30, more than 30, right? Or whatever that thing is. Like, so you can form different groups, right? So, and you can always manually form the groups, but when you have hundreds and thousands of variables, then how do you really form those groups, right? Which of those variables are going to come in significant is what this algorithm really does, right? So what variables come to the top of the list? And remember, there is only x's, there is no y. So using those x's, how can you form groups? And when you say groups, what does the group really mean? So let's say I formed three groups: group one, group two, group three. What does it really mean? Classification will be something different, but what does it mean is that they are similar. Yeah, so group one is similar to each other, but it's different from the other groups. So I hope this everybody gets right. So they are different. Group two is different from group three. Group one is different from group two. But within the group one, people are similar to each other. That's what a group really means, right? So, like, I mean, let's say we are looking at country as a whole. Everybody who lives in India, who's a citizen of India, are Indians basically, right? So that's one thing which is, and then they are very different from Bangladesh or Pakistan or Burma or some other country. So that's what basically this is. Like you're similar within the group, but you're different from each other. If group one is exactly similar to group two, then there's no point in doing the grouping at all, right? So that's where the difference really lies. So clustering tries to do this, that people who are gonna be grouped together, they will be similar to each other, and people who are in a different group or different cluster, so to say. So instead of calling it the cluster, the groups, we can call them in the statistical language as cluster one, cluster two, and cluster 3. So that's what the clustering algorithm tries to do. Is that clear concept-wise? KNN is a classification. It's a supervised learning algorithm. You know that, I mean, I know that there are like, defaulters, non-defaulters. You're saying, is this person a defaulter or non-defaulter, right? Here, we don't know how many classes do we have really. Do we have 3 groups or do we have 5 groups or do we have 10 groups, right? Depending on what you're looking at. So it's like, completely on the fly. Once you have done the clustering, then you get your label. Then you can say, okay, I know that this is, cluster 1, this is cluster 2, this is cluster 3, but you're trying to get the label. You're trying to define that cluster itself, right? So for example, this is a very good example I was looking at from the marketing point of view. Yeah, so for example, customers, right? When you're looking at, let's say, I don't know, Chroma, for example, right? So Chroma may be doing some customer segmentation, right? So what then the customer segmentation may look like? People who are bargain hunters, right? They will only come when there is a bargain in the store, right? And that is true for like, most of us, we come in when there is a bargain, right? Then there are people who are brand loyalists, for example. Anytime there is an iPhone released, it doesn't matter whether iPhone is released for, 2 lakhs or 3 lakhs or, whatever that amount is. I mean, beyond within a certain limit, they will come and buy it, right? So they are brand loyalists. So they don't really care about your prices. I mean, they care about the brand and then innovation and stuff like that, right? And then there could be premium buyers, people who are looking for premium products. I mean, so they're saying more expensive the product, better it is for me, right? There are people like, fragrances, for example. If you sell a fragrance for 10 rupees, and no matter how good the fragrance is, nobody's gonna buy your fragrance. They'll say, what are you selling for 10 rupees, right? If you take the exact same chemical and sell it for 1 lakh rupees, now suddenly the value has gone higher in people's mind, right? So that's where the different products really come in the segmentation that you're looking at and how you have to pitch your product. It's form of a broader strategy. I'm going into a little bit of the marketing lingo. Something we follow in marketing is called the STP, which is the segmentation, targeting, and positioning, right? So how do you want to segment your population? Then which segment you want to target, right? So Suzuki, for example, Maruti Suzuki doesn't say that I'm targeting the premium four-wheeler buyers, for example. So they'll say I'm targeting people who are more conscious about the fuel economy, right? Their first vehicle and all of that, right? So that's what they're targeting. And then that's how they will position. So they will say, you'll get 25 miles per gallon or 23 kilometers per liter and all of that, right? Premium products like, let's say, I don't know, let's say Land Rover, for example, will never say I will give you 10 kilometer per liter or 25 kilometer per liter because that's not their value prop is, right? I mean, they're targeting a very different population altogether, right? The segment that they are going after is the luxury segment, right? People who really want to make a lifestyle statement that I have really made it, right? I'm much better than you are. Right, so they will buy more expensive the vehicle, better it is for you, right? That's why people pay, 110% or 130% extra tax on buying these premium vehicles because they have to make the statement, right? Yeah, go ahead.
Question will be, within, say, what would be having. So which model they want to create, I'm selling to, let's say, 1 crore plus income group. Or let's say Chanel, they will have different ranges and they say, number 5 will be for this category of people who like to spend more for. So within the product categories, actually.
Within and between the product categories as well.
So it is like a different cluster altogether.
Different cluster, yeah, that's right. Yes.
Safari is equal to market, Mahindra XUV. So they are clustering from different brands.
Yeah.
Within the this particular like that would be.
Within the company, it is fine what you're saying, Anupam, but I'm also saying like, let's say you are a Tata versus BMW, for example, right? By positioning, I mean that the BMW advertisements will not be there, for example, in metro, right? Tata advertisements will be positioned maybe in a metro, that people who want to buy their first vehicle and stuff like that. So that's what the positioning is really all about. So how do you want to position your product in front of the consumer, right? And in front of your target audience base. So I think first of all you have to understand is that for any product, any services, there's going to be a lot of different segments, right? One company cannot go after each segment. It's just not practically possible that you can do everything for everyone. You cannot make everyone happy. I mean, we have all heard that, right? So if you try to make everyone happy in your life, who will be the unhappiest person? You will be the unhappiest person. Yeah, that's right. You cannot keep everyone happy. So that's why a company cannot go after every segment out there. They just cannot, right? So it's just impractical. So you say, okay, I have segmented, then I know which one I want to target. Now, if I want to, let's say I'm in the business of making the ladies' handbags, right? For example, how do I want to position myself? What advertisements? Where shall I, have the placement of the product? Who should be my brand ambassador, for example, right? So if let's say I'm making ladies' handbag and I sign up, let's say Arpan as the brand ambassador for it, right? Right? It's not really connecting with your audience, right? Versus if I say, okay, Poonam is gonna be my brand ambassador for selling the ladies' handbag. So I think that's gonna be a different, value prop altogether. So that's the whole positioning thing I was talking about, Tom. Huh? Yeah. So that's the whole idea. Yeah, so that's where I mean, you have to, and this is really very important. I mean, for any product services that you're selling, you must understand how many groups or segments exist, which one I can sell, where do I have the right to be the market leader, where can I be, competitive, given my competencies, given what my product assortments are, and then how do I position myself? So how do I get the visibility and the attention from the consumer? How do I really get my product in their portfolio, right? So that's what basically this is. So in the interest of time, so there is many use cases. So customer segmentation is one of them. Somebody mentioned about the image, right? We can do. I think this is something that everybody can relate to as well, which is news.google.com. Top stories, right? Local news. Uh, for you, whatever I've read, your topics, right? Finance, social science, economy, right? So news are coming in live and they are being sent into one of these buckets live, right? This is a great example of, how your groups are being formed. So based on the content of the news, if I see, dividends, stock prices, dollar, INR conversion rate, finance, it goes in the finance category, right? It goes in this, right? So that's where you can see on the fly, because right now you can say, okay, I can do a supervise also, but then you must know what are all the titles on that day that the news might be coming in. So someday maybe soccer is going to be flying really high, right? So why would you like to have a soccer category when soccer is not being played anywhere in the world, right? So on the fly, news are being grouped and then shown to the user depending on what we're looking at, right? There are many examples that you can go through, but I'll move on in the actual statistical part, right? So what does it do really? Okay, I shouldn't have closed that because there was something that I asked. Can I get it back? No, I cannot. Okay, then I'll come back to it later on. So then we can probably zoom in. What does it do? Algorithm really is something which is there in this picture, right? So you can see when we start, this is how, and this is a very clear-cut example. So there's you can say no-brainer. I can see there is 3 clusters, right? What are the 3 clusters? 1, 2, and 3. You can see, right? But this is how you're gonna start. So let's say you have feature 1 and feature 2. Feature 1 could be your age, and feature 2 could be your income, right? So what you're looking at, age and income. So these are the people who are lower on the age, low on the income. These are the people who are high on the age but low on income. And these are the people who are like low on the age and high on income, right? So high achievers in their life or whatever you want to say, right? So let's say I didn't know that there are three clusters. So how would we form the cluster? So you can say, okay, K means clustering. K means can be broken out into two parts. K means the number of clusters, the number of clusters or the groups you want to form, and means meaning it basically follows something called as a centroid method, which is at the center of the k-means algorithm. So it says, okay, you need to tell me how many clusters you want. And then I will tell you using my centroid method, what those clusters look like, right? So in this case, I say, okay, fine, you form three clusters. So it says, okay, fine, because I am a k-means cluster, I will work with the centroid methodology, right? So what does a centroid really mean? It will drop certain anchors. So this is your centroid 1, this is your centroid 2, and this is your centroid 3. So it will drop those anchors in that two-dimensional space. So it'll say, okay, one centroid or one cluster center is people who are earning on average 10 lakh rupees and they are aged 30 years, right? And then similarly, it will say the second center is people who are earning more than 50 lakh rupees and aged more than 35 years or something, right? And then there's another center that it is there, right? And then let's say I'm a point right here in the middle. So I'm a point right over here. So once the centroids have been randomly dropped in that n-dimensional space, it will say, okay, which centroid you should belong to, this point, right? So what it's going to do, it will compute the distance. So distance 1, distance 2, and then distance 3. Is everyone with me so far? So this point in the middle, we didn't know whether this belongs to centroid 1, centroid 2, or centroid 3, or cluster 1, or cluster 2, or cluster 3. So I'm going to compute the distance to each of these centroids. So which one do you think you should belong to? Because this is the smallest distance, so it says you belong to this centroid, right? So the initial assignment happened. So what happened really? I said, please form three clusters. This is fine. I will randomly assign three center points. And then for each of the points, I will compute the distance to each of the center points and then assign you to the center points where you are the closest. Everybody's with me so far? What is going to happen? Now you have the assignment. You have the assignment done. But what does the centroid really mean? That you are the center of that point. You're the center of that point, right? In this case, yellow. Do you think the red is the center of the yellow group? No, it's not, right? So centroid says, by the way, I'm at fault. I need to be in the center of these guys. So the centroid itself will move. So now the centroid has moved to the bang in the center of those points, right? So initial centroid position has not changed. So you can see this point has moved over here. This point has moved towards slightly bottom right. And then this point has moved towards the top left, right? So centroid have themselves moved. Once the centroid moves, point will say, wait a minute. I thought I belong to that centroid. Now I have to recompute my distance. And then again, the points reassignment will happen. The points reassignment has happened. Centroid will say, time for me to move now, because I'm not in the middle of the center of your points. And this process keeps on happening until there is no change in the membership. The centroids do not move, or you have already run, how many times you're going to do it? You cannot just keep on doing the infinite number of times that, okay, you move, I move, I move, you move, right? So at some point you say, once you've done it for 100 times, just call it quit. You're done. And that's the k-means algorithm in the nutshell. Is this clear? Yeah.
So fixing the case, defining for maybe I will tell.
That's what I was going to come to. So the main thing over here is what is the right k? How do we know whether 3 centroids or 5 centroids or 6 centroids or 15 centroids you should be looking at? So that's what I'm going to explain. You had a question as well, Santosh?
Random, right?
Hmm.
So can you see that random what rules he has taken basically in program?
In the algorithm itself, there are different methods for initialization of the centroid. So it's not completely random. So it follows a certain way that, okay, if I look at this data space, I think these are the, like, the appropriate centroids that I should be looking at, right? And there are many ways of initializing that. So it's not 100% randomly, but like, you can play with some of those settings and you can see how it really comes in. So once you have done that, then this process repeats, right? But this right here, the initial centroid allocation is dependent on the algorithm also that you're using. K-means plus plus or K-means, and there are different variations of that as well. That's how it works. Yeah. No, you form your centers. I'll explain that. So the one way of measuring your success of the K-means algorithms is some of the things that we're gonna look into later on. Oops, too big a data point. Yeah, one way of measuring the success of your centroids is the scree plot, or what we call as the elbow plot. I will explain that in a minute. Then we have the silhouette score as well, right? And then we have, what I mean is the most important is, can you describe your clusters in plain English? Right? Can you really name that cluster? What are the standing features of that cluster? If you cannot name your cluster, if you cannot explain your cluster in plain English, then probably you haven't built the right cluster. So even with this statistical sense, but you cannot. So for example, what could be the clusters that you have built? Discount seekers, right? So discount seekers meaning they only shop during the discount time. So they will come in for the Big Billion Days or Great Indian Festival or, Republic Day and all of that. Then they never shop. Like if I'm Amazon, so I'm saying, only people who shop during these days are the discount seekers. Then let's say I have formed another cluster where people who are doing a lot of grocery shopping, right? They're buying not necessarily electronics and everything, but they're doing the Amazon Fresh order, for example, right? So these are the people who are the everyday grocery shoppers, right? So you can see I can define in plain English what those clusters are. So that's also another criteria that you should be using. And when we come back post lunch, you'll be doing clustering on a very different data set that you haven't seen ever in your life. And we'll see, how you're naming your clusters as well, what you're coming out. That's going to be your assignment. But I'm just going to go on and explain you the concepts first, right? So cluster is a group of data points which are similar to each other. And the centroid is the mean position of all the points. So far, everybody's with me? Yeah. The centroids are recalculated, and it's going to go through this. The number of k is known and fixed in advance. So what are the assumptions? The number of k is known and fixed in advance. We'll be doing some optimization. And the clusters are roughly spherical in nature. So your cluster should not be like this, for example, right? So it assumes that your clusters are more or less round, right? So because I'm computing the distance and all of that centroid, so if I place a centroid distance computation, you can see it's going to be a little bit haywire if I have, that sort of elliptical. So it prefers that you have the spherical clusters for the algorithm to really come out with a better one. And algorithm is sensitive to the initial placement of the centroids, and so on and so forth. And the distance, what is the distance that we use? We use the Euclidean distance as one of the main ones, which is nothing but the clusters and the dimension 1, and how far is data point from dimension 1 of that centroid. So remember, when we are looking at the income and age, oh sorry, I think we had the age on this axis and we have the income here. And let's say the centroid was this, which is the age of 30 years and income of, I don't know, let's say 15 lakhs. So this is the centroid. So for the next person who is coming in, so let's say the income is 23 lakhs and the age is 23 lakhs and the income is 12 lakhs. This minus this, and then keep on doing for n number of variables. You will be looking at the Euclidean distance coming in from there. Yeah. And then the centroid is nothing but the arithmetic average of that. And then we look into something called as a inertia. And that's why I was asking Copilot to explain it more visually for you, but I think I've lost that. So that's okay. Inertia is nothing but let's say we define a cluster, and let's say we have these data points within the cluster, right? And this is the centroid of the cluster. So distance this, sum of square distance, and it's called sum of squared error, SSE. Right, somewhere it's mentioned over here, or if not, then it's there somewhere else, right? So squared distance, inertia between each point and its assigned cluster. So when you're forming your cluster, it is trying to lower your inertia. Inertia is nothing but the sum of squared error for those data points within the cluster. So what it is trying to do is it's trying to say, can I form a very close cluster where everything is close to each other versus, a cluster which might be really big, right? So it's trying to shrink down the size of the cluster, right? So that's what basically the function of the inertia is, and that's what we use for doing the optimization, right? Let's carry on then in interest of time. It's sensitive to outliers, definitely, because everything you're doing is for the distance. So what are you going to do? First of all, you will scale, and then you will normalize. I mean, you'll first normalize and you'll scale your variables before you do any clustering algorithm, right? And so on and so forth. So let's just walk through one quick example of this.
For example, in some cases, if the point of favor point, which is the equilibrium distance equal to two segments, then which one equilibrium?
Yeah, so we look into some of the other more sophisticated algorithms like the fuzzy clustering, right? So, or the probabilistic clustering as well. So they don't belong to one cluster. So they can be membered in two clusters also. So you can have those which are more non-deterministic. This is more deterministic. So this will be assigning you to one cluster only, right? But you, so wherever your distance is coming out to be closer. So like both are same. So then it will be belonging to the first one. Yeah. But you can have a fuzzy logic and fuzzy clustering where you can be part of multiple clusters depending on the characteristics that you're looking at, right? So I'm just going to walk you through the code, nothing unusual. NumPy, Matplotlib, and this is there in my blog, so you can copy paste and run it. Make blobs. Does anyone know what is this? Synthetic data generation, right? So I'm generating 300 samples. And I'm saying generate the 300 samples in a way, blobs meaning, chunk of data, in a way that naturally there are 4 clusters which are going to emerge, right? And the cluster standard deviation, like within the cluster is going to be 0.6 and, the random state is 42. This is where, I'm tricking this because I already created the data that I would like to see, right? So I'm saying, please create the data which shows me 4 clusters down the road. I think this color is not really visible on your screen. 4 clusters, right? So it is going to come out with this, right? So here, this is where the magic is happening. So what are we doing over here? We are initializing this list called inertia. And then we're going to check the K between the range of 1 to 11. So I'm saying, form a cluster with K equal to 1, K equal to 2, 3 till 10. So you'll form a clustering algorithm with one centroid or one cluster, 2 clusters, 3 clusters, 5 clusters, 10 clusters, right? Like that. And for every time you're going to do the K, you are saying K means number of clusters equal to K. So it will say number of clusters equal to 1. It will form the entire algorithm, right? And you're fitting, you're appending, and then you're computing the inertia. Inertia is what? We were looking at this earlier here. Yeah, inertia this, right? So it's going to compute the inertia. And then continue doing that and so on and so forth. Then it will append and then it will come back with certain number of things. And then and I'll let you guys go through it. I'm not going to explain line by line so you can understand. You're to the point now you can understand. So then we can see that it comes out with something like this, right? So this is what basically is the holy grail for the selection of the clusters, right? So what happens is, so it says, okay, you asked me to build a cluster with one centroid and I computed that inertia came out to be this. Then another, you said 2 clusters, inertia come out to be like this, right? And then so on and so forth. So you can say what is happening. So this is with 1, this is with 2, this is with 3, 4, 5 till 10. Everybody's with me? And what is happening with the sum of squared error or inertia? It continues to drop. It continues to drop. As you keep on adding more and more cluster, that will continue to be dropping. What is going to be the ideal segment size in this class? This is a trick question. No, in this class, what is the ideal segment size? Ideal segment size. 2 or 3. Ideal segment size is 1. Ideal segment size is 1 because there will be no difference between you and you. But let's say if I do the girls one side, boys one side, you'll say Deepika is different from Aishwarya, Aishwarya is different from Thoya, Thoya is different from Poonam and all of that in these regards, right? So even though you're belonging in one cluster, there are still differences between you. You're not 100% perfect, right? So in reality, for marketing, they say I'm doing personalization, right? So they are saying I'm personalizing the product for you. So if Apple can make an Apple which is unique for you, iPhone unique for you, that is like the best, right? You can say you select what you want to do, but it's not practical, right? So the sum of squared error, you should not say it should be 0, that within the same cluster, everybody is the same. It's never going to happen, right? So what you're looking for is the law of diminishing return. And I will come to you, Anupam, since you have the marketing and other business knowledge. Law of diminishing return, or anybody from the economics. Law of diminishing return. Anyone knows?
In the pricing side, what are the
Uh-huh. Okay, let's say you are very hungry. You haven't eaten for 3 days. You're very hungry. Somebody gives you the first roti or chapati. The utility of that roti is like tremendous. Now you have eaten your 10 rotis. Somebody gives you the 11th roti also, right? The utility of that 11th roti is like, coming down and down and down. So if you're adding one more roti, then it may backfire also. You may start vomiting also, right? So that's basically the same thing. So if you have the one cluster and you say, okay, go ahead and have 2 clusters, you can see the error drops like anything, right? And say, go ahead and have one more cluster, please. And then error drops like anything once more. Then you add one more cluster, error drops, but not that much. Then you add one more cluster. Now you can see, okay, it is dropping, but there's not much utility coming in from adding one more cluster. One more cluster is nothing but one more roti that you're already completely full now. So it says, okay, fine. Where do we stop? So the golden rule for stopping criteria is right over here, which is the elbow point. Now, some of you may argue that elbow is also over here, but you can see the drop basically still going from 3 to 4. There's a significant drop, but going from 4 to 5, the drop is not much, right? So you can see the elbows forming over here, and this becomes your golden criteria. So all we have done so far is to find out what should be the right number of clusters to begin with. And it says, your ideal number of clusters should be 4. And then you go and rebuild your clusters. And then every data point will be mapped to a cluster then, right? So you can see now here, every data point is mapped to the clusters. And then you have a centroid, inertia. This one. What is this metric? This metric is the same thing we were talking about earlier, which is this within the cluster, from the cluster to each of the data point, what is the sum of squared error? So it's trying to lower that, right? And then it's just trying to do it for all the clusters and plotting you as an inertia, which is the the overall SSE for the entire cluster ecosystem, and it's trying to drop that for you, right? So you're not gonna go and say, give me the 0 inertia, right? Because that will be too much, right? So you're saying where exactly the diminishing return really comes in, or what we call as a marginal utility. Right. So marginal utility is also, let's say you're completely broke. Somebody gave you 1 lakh rupees, then another 1 lakh rupees, another 1 lakh rupees, right? So And that's basically the value of that, right? So this is how the clustering has been formed. Then we're gonna do the same thing. So this you can do after you back from your lunch. Then we're gonna pretend there is no iris flower label, but we know there are 3 flowers, right? So we'll pretend that based on sepal length, sepal width, petal length, petal width. So let's say you were the, what do we call that? The researcher who just found out the plants, right? And you measured the sepal length, sepal width, petal length, petal width. Now you're saying, okay, how many flowers are really there in this species, right? So you're beginning with that journey. So we'll pretend that we don't know, and we'll say, what is going to be the right number of clusters on the iris? Yeah, it's all there. You have to run the code and come out with this. So you can see we came out and we are doing the same thing using the iris data where we know there should be 3 species. So when we go from 1 to 2, there's a top, 2 to 3, there's a top, 3 to 4 also there is a top. So you can literally make a case that I want to have a 4 species in iris dataset. You can, right? It's like, as long as you can define them, but we're gonna go with the 3 clusters, and these are how the clusters are formed, and some of the things like this coming out from the over here. And then there's another metric called the silhouette score, which is I wanted to describe that with you as well. So it's basically trying to figure out. So one is that you're looking at the inertia or SSE, which is, the within your cluster performance, right? Now, silhouette score measures whether, so let's say there's another cluster which is very adjacent, and it says, okay, are you sure you belong in this cluster or you belong in this cluster? So it's basically tries to measure the membership. This one says, okay, I'm not measuring whether you belong to cluster 1 or cluster 2. You belong to cluster 1, I'm computing the distance. And silhouette score says, okay, I'm checking whether you really should belong to the cluster 1 or not, right? And higher, higher the score, better it is, right? So somewhere we would have defined that. So cluster 0, all of that. And somewhere over here, I saw that score coming in, yeah, over here, 0.551, right? So it is good. Closer the score to the 1, better your solid clusters are, and there's no ambiguity that, whether you belong to this cluster or that cluster, right? So you use both in conjunction, which is the SSE and the silhouette score, right? And that's what basically this is. So once we come back, you will first try to replicate this. We'll do a walkthrough with everyone, and then you will be assigned this brand new one, which is the heart disease data, right? Where you have the ID, age, gender, all of those things, and you form the different groups of people based on the heart disease symptoms and the underlying parameters they are presenting, and define them in the plain English. That's going to be your in-class assignment. Is that clear? Abhi, do we have your blessings now for lunch? Okay. Hmm? It is. We should do the outlier treatments before you. Definitely sensitive to outliers. Okay. So on that note, let's take a break. Be back by 2:30, and then we will begin. You guys will begin the hands-on exercise on whatever we have done, and it's all there in the blog, right? So you can just copy paste and run it and explain. I'll pick randomly some of you to explain, and then we will begin the heart disease one, and then take it from there. Thank you. Sorry? Well, heart disease, yes, that's right. I'll send the link on the chat group.